Welcome to today's seminar. What is research data management and how can a depositor help? In today's seminar, we will overview some of the key components of research data management and the practical resources for data management plans. We will also show you how to find research data repository that meet your needs, and we will introduce the depositar, public repository research data that has been developed in Academia Sinica, Taiwan for the last few years. I'm Tinrui Chuang, the project lead of the Depositor Lab, Academia Sinica. The webinar today will be led by 3 key members of the Depositor Lab. Here is Xue, who is sitting beside me, and Lan Tuan Wen, and Jiaxun Eddie Wangs. In the past, the Depositor Lab has organized a research data management seminar and workshop, primarily for the audience in Taiwan, and they are conducted in Mandarin, the common language we use in Taiwan. But we also receive requests from international scholars and students in Taiwan asking us whether such seminar will be held in English in the future. Today's outreach event is the first ever outreach we conduct in English. I wish to remind to mention that English is not our first language or even the second language for many of us in the room. So please bear with us that if our English is not as fluent as we would like. The Depositor Lab has been supported by Academia Sinica. In Mandarin, it will be 中央研究院, and also by research grant from National Science and Technology Council of Taiwan. I think I now can hand over to Hilary to start today's webinar. Thank you.
So thank you, Professor Zhang, for the introduction. And so my name is Hilary. I'm one of the newest members of this lab. And at the moment, I help promote research data management, RDM, and data management plan, DMP, at the lab. So I'll cover the first half of the webinar and pass my mic to my colleagues, Ali and then Lan Tuan. So this visual on the slide is probably very familiar to you because it's used on our poster, registration form, and also our welcoming page earlier. And this is where the original idea was from. It's a presentation slide from 2018 by Sarah Jones at the International Open Science Conference. We thought it provides an ideal overview of research data and why research data management is important for open science. So one important aspect of open science is to make scientific knowledge openly available, accessible, and reusable for everyone. That extends beyond the traditional scientific communities. And one way to achieve this is through good research data management practices. So in this figure, we see that only a portion of all the research data is being managed, and only a portion of it is fair, which is findable, accessible, interoperable, and reusable. We'll look at that in a little bit. Some of the open data is being managed, but some of it is not, and only a very tiny portion of it is managed, fair, and open. So to achieve the goal of open science, we hope that little yellow area can grow bigger and bigger. And RDM is fundamental for open science because it ensures that data is fair, properly preserved, and that enables transparency, collaboration, and hopefully long-term use. I hope this provides you with some context on why we're talking about RDM, data management plans, and research data repositories today. And after today's seminar, we hope that you have an understanding of research data management, research data lifecycle, and the FAIR principles. Know where to find data management plan resources if you plan to write one. We will also provide some resources and guidance for choosing a research data repositories. In the last part of our webinar, we will introduce the depositar, a repository that our team has been developing as an instance for data management, sharing, and preservation. Since the FAIR principle will appear throughout the presentation, I will provide a bit of background information here. So they are established in 2016 in the journal article, The FAIR Guiding Principles for Scientific Data Management and Stewardship. As you can see, this is mainly for research data management. And what is important in these principles is that they emphasize machine actionability. That is the capacity of computational systems to find, access, interoperate, and reuse data with none or minimum human intervention. And this machine actionability is important because in contemporary sciences, we increasingly rely on computational systems to work with data because of their complexity, and the amount of data is too much for humans to manipulate. I will go into the definition and provide some practical use case for each of the principles here. First, findable is that metadata and data should be easy to find for both humans and computers. One example is using persistent identifiers because they help humans and computers or machines to find the specific information resource they look for. DOI, ARK, ARC, and ISBN are all examples of persistent identifiers. Another way to increase findability is using rich metadata and index them in a searchable resource. For example, data sets on depositar that have enough metadata information are indexed and findable via Google Datasets. Many research data repository utilize this function as well. So the box below is the requirements for using for repository who wants to use this functionality. They have to supplement enough information. The second principle, accessible. It is once the user finds the data, they need to know how they can be accessed, possibly including authentication and authorization. For example, a data set with an ARC identifier can be retrieved via ARC. And specifically for ARC, they use the HTTP 302 standardized communication protocol. And for the provision A2, it's more special. It's that metadata are accessible even when the data are no longer available. And the Thomson page on depositar is an example for this provision. So if a data set on depositar is no longer available, but it has an ARC identifier, then instead of getting an arrow 404 not found page, the user can still see the electronic resource citations metadata information like appear on the right bottom side of the box. The third principle, interoperable. The data usually need to be integrated with other data, possibly with applications and workflows for analysis, storage, and processing. To increase interoperability, researchers can use metadata standards or control vocabularies that are widely used in their domain, like Darwin Core and RDF for more general research data. And then there's also Dublin Core and then data catalog vocabulary for data set. Some control vocabularies that are widely used include ISO 8601 for date and time. There's also Getty Thesaurus of geographic names. It's a name thesaurus. And taxonomy is also used widely, like in biological science. So essentially, these standards help humans and computers to understand and process data and metadata more efficiently. If you don't have to do, if they are standardized to some degree, then you don't have to do as much data cleaning. The last principle is also the ultimate goal of FAIR, reusable. This is to optimize the reuse of data. To achieve this, metadata and data should be well described so that they can be replicated or combined in different settings. On this slide, the temporal and forest type related dynamics of morph assemblages research is an example of reuse of data from different sources. Their data set include morph specimen data set, citizen science data from Facebook group, and weather data by Taiwan Central Weather Bureau. So how these data are reusable really rely on both their data and metadata to have good quality. And to enhance your data reusability, one of the simplest way, if we don't look at the data quality, is to think about what data usage license you can use for your data. Like a common one is Creative Commons license. And sometimes if your research data is software code, then you may consider using MIT license or GNU General Public License. So this is the basic introduction and some examples of the FAIR principles as background information. And after knowing what FAIR is about, we will then go into RDM and DMP, and we'll take a short break. And then my colleague Ali will introduce research data repositories. Afterwards, Lan Tuan will introduce the depositar and explains how it supports FAIR data. We will then conclude our meeting with a Q&A session. Okay, so we have mentioned many times research data management or RDM, but what is it when we talked about RDM? Here we are providing a working definition of RDM from CODATA, Committee on Data of the International Science Council. This is an interdisciplinary scientific committee that promotes principles, policies, and practices for open data and open science. So in this definition, it emphasizes that RDM practices cover the entire life cycle of the data, from planning your research, collecting data, processing data, to publishing it and long-term preservation of the data after research. This terminology document is pretty useful if you want to have a shared understanding of what research data management terms. So what does the research data life cycle entails? Using this figure may make the life cycle clearer. And this is created after reviewing a few life cycle models. The main two are referenced here on the slide. And what we'll talk about next is some good RDM practices for each step. And what we mean by good is based on how well the data aligns with the FAIR principles and contributes to the goal of open science. So the first three steps involve planning your project, collecting, creating your data, and then processing them. A data management plan may be useful in this step, and we'll talk about data management plan later too. And some helpful things to do, including using the 6 W's to think about your project, like what is your project about, what is your data, when and where this research is taking place, who are involved in the project, who are your stakeholders, why is this important, and why you make some certain decisions, and how this data is conducted. So all these details help people understand your project, and this could be a future you reviewing or reusing your own data too. So for collect, create, process, and analyze steps, a common good practice is to document the actions you take, like where you get your data from, how you transform your data into an analyzable state, and then what methodology, models you use. All of these documentation helps with publishing your result, your data reproducibility, and also make your data more understandable and reusable. So after that, one of the most important steps is to publish your research finding, like an academic article or data paper and so on. After publishing the deliverables, it is time to think about what data have long-term values for preservation and what can be discarded. Preserve and share, these two steps are often interconnected because they usually are achieved together by using data repositories. So at these steps, you can consider what repository may be useful for you, what functionalities are important for you. My colleague Ali will talk more about this later and provide some resources. Lastly, there's one centerpiece that we have not touched upon, which is data storage that's right in the middle. It means that throughout each stage of the life cycle, you need to make sure your data is secure, like backing up your data properly, ensuring data privacy and data security, especially if you have sensitive data. And one research data management challenge is losing your data, as seen with the researcher feature in this news story. In their case, valuable research data was lost, but while data may sometimes be recoverable if you have good backups, it's important to note that losing sensitive data, especially when it is not encrypted, it poses serious ethical concerns for your research. And other than immediate consequences, there are also long-term implications if you do not practice good research data management. And in this comic, the researchers found data on the ground, but they have no idea what it is because there's no metadata, which is data that defines and describes the characteristics of other data. And metadata helps us understand and reuse data. This is why when we talked about FAIR, RDN, and life cycle, documenting your processes and contextual information about your research is all very important. They are key to understand what your data is about and potentially how they can be reused. Here are some other reasons you may want to practice good RDN. Some are mandatory, like funding requirements, ethical and legal compliance, but there are also advantages for your own research. Like it helps you to better organize your data, collaborate with others, preserve your data, create fair data, and achieve scientific data reproducibility. And how exactly can we put RDM into practice? Using a data management plan may be a good start. A data management plan in CODATA's terminology definition, it is a statement describing how research data will be managed throughout a specified research project's lifecycle. And they stress that it is a living document, so they can be updated when necessary. What does a DMP usually include? Here are the 6 core requirements for data management plans from the practical guide to the international alignment of research data management. This is developed by Science Europe, an independent association that represents national research organizations across Europe. So in this guide, they categorize 6 core requirements for DMP shown on the slide. And I won't read them one by one, but we will look at them in a demo video together. In this video, we will take a look at how each core requirement maps with actual data management plan. This is the section translating the core requirements into a DMP template in the practical guide by Science Europe. The template has 15 questions in total to cover the 6 core requirements. They use detailed explanations to let users know what kind of information you can include to cover the 6 core requirements. To make this less ambiguous, we will use 2 actual data management plans to demonstrate what kind of information you can put in your DMP. The first DMP example is called Digitization TCM Collaborative Research. It is in biological science, and this DMP was found on DMP tool website under public plans. This link will be included in our slide, and we will share the slide later in the future. For the other DMP we're using is called Teaching Quantitative Data in the Social Sciences at the University of New Hampshire. This one was found on this DMP competition winners announcement. And this is from a qualitative data management plan competition. So if you collect qualitative data, this list may be useful for you. Back to the template. Before getting into the actual core requirements, they have a section for general information, that's administrative information. And in digitization TCM, they mention about creator, principal investigator, data manager, funder, and note here that they put start date, end date, and last modified date in this document, indicating that this document is subject to change and there may be other versions of DMP. For teaching quantitative data in social sciences, they have information in the first 2 paragraphs in their DMP, and also in their institutional repository, they have abstract about their DMP. Now let's get into the first core requirement, which is data description and collection or reuse of existing data. In digitization DCN, they are digitizing herbarium data from tropical Africa. So here they are creating 4 types of data, including programming code. They also mention how they are creating these data. For teaching quantitative data, they talked about interviewing up to 15 participants, and they mentioned the file types, file formats, and then all the project material will amount to this size. So these are all examples about information you can use to fill the first core requirements. On a related note, if you are reusing data from other sources, this is where you can talk about how the data provenance will be documented as well. The second core requirement is documentation and data quality. In digitization TCM, it is in biological science, and they mention many standards widely used in their field, like Darwin Core and IDIC Bio guidelines for their images. And for their programming code, they will document within the code and outside of the code. For teaching quantitative data, they will record metadata in the spreadsheet and also document methodology and then qualitative coding approach, etc. For this requirement, it is helpful to talk about how you perform quality control, how you ensure your data is good and consistent, and then what methods are you using to achieve these. And the third core requirement is storage and backup during the research process. In digitization TCN, they mentioned using version control code repositories, and then specimens are being stored and managed at the institution where they are deposited, and then they consider if a service backup are good in case of disaster, and then identity management is also considered in their data management plan. For teaching quantitative data, they are using university-approved, password-protected cloud storage for their human subject research, and only 3 research team members will have access to the all the project materials. So for your DMP, you would want to think about data backup and also sensitive data security and protection. For the fourth requirement, legal and ethical requirements, codes of conduct. This is slightly connected to the previous one because storage is one place where researchers have to put legal and ethical requirements into practice. So you can consider these two together. In biological science, sometimes they have sensitive data. So they mention here data of sensitive nature will be withheld or generalized, and they may use Darwin core fields like information withheld and then data generalizations for release of sensitive data. In teaching quantitative data, they talked about the process, how they ensure personal identifiable information is safe with them, like they will de-identify metadata and data, and then these data won't be made publicly available. Again, the third and fourth core requirements are kind of related, so some information may fit in for both. The fifth core requirement is data sharing and long-term preservation. In digitization TCN, they mention using data aggregators like iDigBio and GBeef to share data, and then georeference location will be incorporated into the biodiversity enhanced location services. And they all adhere to the idea of open access, so aim to publish in access-friendly journals. For teaching quantitative data, they mentioned that the codebook, interview protocol, associated documentation for the data and analysis necessary to replicate the study will be included in the final local report and published in their institutional repository. The team members and future collaborators may reuse the de-identified interview transcripts, and also the identified data, metadata, and records will be retained for 3 years and reappraised in the future. So in this section, things to consider include what data to preserve for the long term, why, and then what platform can enhance your data's discoverability. is there any data embargo reasons, and if there's any retention period for your data. The last requirement is the data management responsibilities and resources. Here you want to document personnel involved in your research project and who is responsible for what. And other than division of labor, you can also document things like staff time, cost, and then list required resources in this section. Research team members may change during the period, so remember that you can always update your DMP. So these are the 6 core requirements of data management plans. I hope this video is helpful for you. These are the 2 examples shown in the video. Data management plans are not only just a concept, it is also being practiced in many different countries, like the US National Science Foundation, US CDC, and in Europe Union, there's Horizon Europe, and in Japan in recent years, the Japan Society for the Promotion of Science. All these institutions have been requiring researchers to supplement DMPs when they submit their funding proposals. For Taiwan, the National Science and Technology Council also encourages researchers to incorporate the DMP plan into their research projects. But right now, we don't have mandatory policy or national-wise policy yet. This is the US NSF requirement example. They require a 2-page data management and sharing plan for part of a proposal to the US National Science Foundation. For Horizon Europe, they also require researchers to publish a data management plan and regularly update it. More special here is that they also require researchers to share data via the repository with the principle as open as possible, as close as necessary. For Japan, the Japan Society for the Promotion of Science is a national organization to promote science and innovation in Japan. They released this policy 2 years ago, last year. Researchers in charge of research activities conducted with research funds granted by JSPS shall prepare DMPs as required for each program. And as I mentioned earlier, Taiwan doesn't have a national policy for this yet, but the National Science and Technology Council, which is a national institution that supports the advance of science and technology in Taiwan, in their Department of Natural Sciences and Sustainable Development, they promote academic research on sustainable development and want to promote the quality control of scientific data. So they are, in recent years, encouraging people to incorporate data management plans as well. Here are some data management guide and tool. If you are interested in writing one, we will maybe recommend you to take a look at the data stewardship wizard, the last item on the slides. It uses a questionnaire for users to customize your own data management plans. So you are not filling a static form, but you are kind of interacting with their platform. And it is also an open source platform. And if you're interested in reading more about available data management plans, here are some of the resources you can find online. For Mandarin Chinese ones, you can see in the last item on the list, on our depositar repository, we have some Mandarin Chinese DMP example.
Thank you, everyone still on here. Welcome back. So I'm Joshua Wang. You can call me Alice. In the first part, my partner here will introduce the research data manager is and explain the data lifecycle, their principle. In this part, I will provide a brief summary of what is research data repository is, and how to choose the right repository based on your domain and your requirement. And next, my colleagues, Lantuns, will introduce our service, depositar, and demo. Okay, I hope our demo will be okay in that time. Okay. So the first question we always answer why, and I also want to answer why our technical have something wrong. Okay. So why should I put my data in a public repository? Or why should I manage my data to the others? And that will be spent so much time on me. So they have some strong reasons for you cannot skip that. The first, once you ensure that your data is discoverable, citable, reusable, and also your metadata and preference information are accurate and accessible, that will make the other researcher can easily find and reference your work. Okay, and give you credit and boosting your research visibility. That would be a positive circle. So promote best practice in research data management alongside push more data openness. So, and of course, many journal and funding agencies now require data share as part of their policy, as we mentioned before. So using the public repository make it easy to fit those requirements. So that's one. Share your fair data in a data repository is open up opportunity for others to build on your work. There will be possible bring some new perspective and make open science as a collective production. So how do you choose a repository data? How do you choose a research data repository? Here are a few tips for your reference. We suggest the document from Science Europe. They have a chapter about the criteria for selection of trustworthy repository. They are recommend 4 directions. I will be pointing out the most important ones. The first, make sure you choose a repository that provide persistent and unique identifier. We call it PID, such like DOI or ARC. And it's important to allow your data discover and identify, enable searching, citing, and the discover of your data and provide support for data versioning. Second, the repository should provide metadata specific that use standard accepted by your scientific community. And also ensure they are machine readable, even for non-published, protective, or delete data. So the third one, the data access should be enabled under clear conditions, support retrieval and providing licensing and permission information. Those should be machine readable too. So the last one, ensure persistence of metadata and data, and also need to make sure the repository prevention policy plan and financial sustainable and so on. So make your data long-term presentation. That was the important one. So how should we search a suitable data repository for your domain? Here is a simple way to easily find repository you can visit, registry data, or share. which there's over 3,000 repositories from around the world, cover different subject, content type, country, even more. You can simply use the filter function to find what you need. Such like life scientist repository EMBL or GBIF, the world's biggest biodiversity data repository, or knowledge commons open access for the humanity, or Pangea is Earth and environmental scientists, or Pandora's is open data platform for a human story, or CORD is an open access repository for crystal structure for organic or inorganic. So they have so many kind of repository in specific domains. If you are a cross-domain research project, you can use the generalist data repositories such like Nelodo. Is operated by European organizations for nuclear researchers, or the support by academia data repository. Depositar is our support. So those repositories have the common features. Anyone can register and can upload their data. It's open access and open for all. So in the next sessions, my colleagues, Nantuns, will introduce the Depositar. It was a research data repository service what we provide. Thank you.
Good morning, everyone. Sorry. Good morning, everyone. Thank you for joining our webinar today. My name is Tung, Hillary and Ali colleagues, and also a member of the Depositar Lab. And thank you, Ali, for your very concise and helpful representation. On selecting appropriate research data repository to ensure long-term reservation and accessibility. And now I'm glad to share with all of you one research data repository that our Institute of Information Science developing for the last several years. So some of you may know that various research data repository cater to various diverse needs today, ensuring data is well reserved, reusable, and accessible. For example, like Zenodo, as Ali mentioned earlier, it is supported by CERN, provides a free and open repository for all disciplines, integrating with GitHub for seamless data archiving. And another platform is our Depositar. It emphasizes fair principle for a tool to manage and share research data. So whether you're working with tables or maps or documents and other data files, Depositar allows you to upload and review your data sets easily. And each data set can be given a persistent identifier, and you can enrich your upload by detailed metadata, helping others discover and reuse your works. So generally speaking, Depositar is an online platform to manage and sharing research data, simple and collaborative. It is supported by Institute of Information Science and Research Center for Information Technology Innovation, both of them in Academia Sinica, and is built on CCAN, an open source software for publishing open data. So for more information, I will put a link in the chat box for your reference. Depositar also serve diverse community, including researchers, institutes, organizations, and so on, enabling the managing and sharing research data. Like other repository, Depositar is free and open to all users. It is designed to meet fair principle. And in July, it introduced a service, terms of use, and privacy policy. Moreover, Depositar offers enhanced features like Wikidata are the source of keywords or persistent identifier like PIDs, citations, data preview analysis tool, or project team management. Supporting collaborative and transparent research practices. So here, several projects already created on Deposita. They are Ocean Biodiversity Listening Project, Thakbong, or Asian Ecological Observation Network. To be more evident, I will give you a sample of the data set on Angan Drift soundscapes conducted at Taoyuan and Taiwan. So this data sets demonstrate very comprehensive feature of Deposita, including detailed description of data set and project, as you can see here in the top part of this picture, alongside linked data and external resource as below for further exploration. And the data set here is enriched by text and Wikidata keywords, offering enhanced discoverability. And key components here include basic information, spatial temporal information, and management information. So they are all documented on Deposita. And this data set of Angan Drift soundscapes is licensed under an open content license with identifier ARC, integrating with ByteHub for dynamic data analysis. And Deposita also features citation snippet for proper data endpoints like JSON API or RDF serializations. They are on SICAN standard offering, ensuring raw usability and accessibility. So because the sample here is quite long, I cannot provide you whole of this, so let me give you more detail. So here, Angan Drift soundscape, it belongs to the Ocean Biodiversity Listening Project. So the title of the project will be shown on the left tone bar, as you can see here. And the author of this data set, they have chosen CC BY 4.0 license to allow others to manage and share, reuse their work. When it comes to license, we recommend 3 types, like CC0, CC BY 4.0, or CC BY SA 4.0. It depends on your needs. Particularly CC0, it is Creative Commons 0. It will place your work in the public domains, so no attribution is required, and anyone can use, share, modify, distribute it freely, even for commercial purposes. Another one is CC BY 4.0, is similar one the author here used. So it is Creative Commons attributes. Creative Commons attribution is allow others to share, adapt, and use the work even commercially, as long as they credit to the creator. So BY here, attribution is mandatory. Finally, CC BY SA, quite similar to the previous one, but any adapted work must use the same license. And SA here is share alike, mean attribute adaptation should be use the same term. Another feature on Deposita is ARC identifier. So Deposita provide persistent identifier to the data sets with condition. I mean, if the data set provide enough information, so Deposita will give it an ARC link. And here the data set from the Angan Drift soundscape, they provide quite enough information like title, start time, end time, creator, and so on. So Deposita generated an ARC link to it. Deposita also features citation snippet, as I mentioned earlier. You can see here on the left toolbar. So it's for proper referencing. And Deposita support more than 1,000 styles like APA, MLA, GCAVO, and so on. It helps mapping between Deposita metadata fields to variables of citation style language. And another available feature, computation. like you can see here, the link. Yeah, to start a computation with data and data set include integrated with ByteHub, so it can help the user to run the Jupyter notebook directly from the platform, then facilitating data analysis. So it's helped for accessibility. So for those who want to learn more about the data set, they can preview the data by using the tool provided here. So, I mean, by clicking this button, user can preview the shapefile of data set directly without downloading it first. So here, the authors inputted spatial information, then the data will extend here. And the depositor also use Wikidata keywords to tag data sets. So the user can easily find research data on Google data by using the keyword here, for example, Sourcescape. And here, the user also of depositar, they can indicate the dataset description with paper size the datasets. Likewise, the corresponding papers will also reference and include the associated datasets. So if your paper already published, you may include a link in the processing when you describe the data. So what can the depositar do for you? Implementing FAIR principle, we hope that it can help ensure depositar values for research data by protecting best practice, by promoting best practice and supporting long-term usability. So to be more precise, when a repository implements FAIR principles, it adheres to a set of guidelines to ensure research data are findable, accessible, interoperable, and reusable. So here is how depositar implements this principle. First of all, findable. Depositar has capacity to assign a unique and persistent identifier like ARC. So it's a method that depositar support findable principle. And if your metadata is rich and more descriptive, facilitate easy discovery for user. Keywords and searchable tags, as you can see here, a link to the resources like it can help enhance discoverability, or intuitive spatial temporal description, as I mentioned earlier. It provides information about datasets, location, and times. So with this, the depositar makes it easy for users to add and interpret this information, helping others quickly understand where and when the data. The second principle is accessible. Accessibility does not only mean free access, but ensure metadata is always open, even if the data is. So here we use the U3C on depositar. It helps structure metadata for each data set in a standardized format, ensuring consistency across the platform. So each data set has essential properties such as title, description, or keywords, publisher, creation dates, and license. And the metadata is machine readable and compatible with all the systems, enabling integration and data. Because it's a part of well-defined hierarchy where the data set can, and the DCAS facilitates linking data set to share to related resources such as publications, tools, or external repositories. For example, a data set on Angan discussing the research findings or other data set in similar domains. The third principle is interoperable. So with depositar, we use JSON data API and RDF serialization. They are own techniques. So this feature enhances data accessibility by supporting straightforward API interaction and sophisticated semantic data in integration. Finally, reusable. A very clear and accessible license, for example, CC BY 4.0. It can help to define how they can be shared and how they can be used. And if metadata include about data provenance, context, and methodology, it ensures dataset can be correctly interpreted and reused. So by implementing this principle, a repository like Depositar support collaborative research, data longevity, and broader accessibility, enabling researcher, institute, and even non-specialized, they can maximize the potential of shared data. So given all the features from the CTAN platform, we can continue to provide our user to make the data sets more findable, accessible, and so another feature that for you is management. So it helps manage data set easily within a team. The screen. When you click this button, this feature will help track changes to the data set and their metadata. To view modification, revert to the previous version, or maintain transparency and organizations. So this feature streamline teamwork and ensure efficient project management in collaborative research. So next, let me give you a demo clip to learn more how we can upload the data set to the Depositar.
In this video, I will demonstrate how to use Depositar. There are two instances of Depositar. One is the production instance. This is our official site. It is at data.depositar.io. The other one is the demo site, which is the test instance, which is demo.depositar.io. If you want to test out the features or functionality of Depositar, please use our demo site. But be mindful that the data on the demo site will be purged from time to time. For example, our next purge is set to happen at the end of this year. Before getting into the details, I want to show the basic infrastructure behind the Depositar. There are two main methods of organizing data in Depositar. There is project, and then there's dataset. In this figure, we can see that there are data sets within project, but there are also data sets outside of projects. For the data sets within projects, they can be set to be public or private. Private in this context means that the data set is open for project members only. For the data sets outside of the projects, they must be public and can be modified by any registered users. This is a behavior inherited from the CCAN package that we use. So if you want full control of what you upload, remember to create a project and put your data set within your project. If you have a project, you can also add members to it, and then you can assign different roles for them. But you can also be the only member for your own project. Within the data set, you can also describe it better with other metadata elements for better findability and discoverability. Last but not least, Depositar is format agnostic. That means that it doesn't restrict what kinds of file format you upload. So here's the basic definition of project in Depositar. They are used to create, manage, and publish collections of datasets, and users can have different roles within a project. There are three types of roles: member, editor, and admin. Also, a project aggregates metadata elements of all the datasets within it. We will take a look at this in the latter part of this video. And here's the dataset definition within depositar. It is a collection of data resources together with a description and other information at a fixed URL. This is what user sees when they search for data on depositar. As I mentioned earlier, datasets can be managed under a project. If they are not managed under a project, then it is public and can be modified by any registered users. But depositar will document all actions in the activity stream. Lastly, datasets can be enriched with detailed descriptions using metadata elements, so your datasets are easier to find and to be understood by others. For details about filling these metadata fields, you can visit our user guide dataset level for more information. Now let's take a look at how to use depositar. If you want to create projects, datasets, and upload data, you would need to register for an account. On the top right corner of our website, you can find the register button to get an account. How we use your data is documented in the privacy policy, and there are also terms of use on our website if you are interested in knowing more about our service. For this video, I will use the demo site to present a use case using my co-presenter Lan's project and datasets. In the private browsing window, I already logged into my demo account. On my dashboard, under my projects, you can see all the projects that I currently belong to, and the one I'm using is the public health policy in Vietnam. I am currently an editor in this project. For other projects, I am the admin. So let's click into it. You can see that there are currently 3 data sets within this project, and it has a lot of detailed information, including project description, and then data set description. Each resource also has its own description. And this data set also includes these Wikidata keywords and process steps information that also address how users can reuse this data. Back to the project view, I want to use a use case in this video, and then there's one file that I would like to add to Qinlan's data set called Misinformation, Disinformation, and Vaccine Hesitancy in Vietnam. This file is her literature review, and they are potentially useful for Qinlan's future studies or for other researchers in the same field. But first, let's take a look at the data set information. And these are already filled by Lan. And there are a few things I want to mention. There's required fields and there's required fields for ARC. Required fields are the fields that depositar need from you to publish your dataset. So all the required fields are, you need to fill in information in those. For required fields for ARC identifier, this is if you want to get an ARC persistent identifier for your dataset, then you need to supplement information for title, start time, end or end time, and creator. Then an ARC identifier will be generated. I also want to mention and showcase how you use the Wikidata keywords field. For this data set, I think we can add in one more keyword, public health policy. And how it works is that when you type in the words, it will do a search on Wikidata and show you all relevant keywords, and you can find the one that fits your description. So this is the one I would choose. For other fields, they are all supplemented. For license, I want to mention that currently it is listed as license not specified because this data set has different types of data, different files, and then including metadata that is usable for others, but for some files they have different types of licensing option. So Lan documented these under the process step. For project, it is listed under the correct project, and we currently want them to be public, so we are not checking this box open for project members only. If you have data set that you want to keep for yourself for now, then you can check this box. And let's click update dataset since we added one more Wikidata keyword. And then the keyword has been added here. I still need to include a file, so let's click into manage again, and then under resources, click add new resource. And then we can upload this PDF file that I would like to include. There's also a description that I would like to add. Just copy and paste it onto the description field. For format, let's put PDF file and click add. Then the data file has been included here with the description and the preview. So this is how you can use Depositar to manage your data. And I want to mention that project aggregates all the metadata fields that the data sets have. For example, one example is this public health policy keyword that we just included has been added to this Wikidata keywords filter. And if you have a lot of data sets within the project, you can use these to navigate and to filter information and find the resource you want. So this concludes our demo video for today. If you want to test out the features and functionality, feel free to register for an account on Depositar demo site.
So here are several slides already put in the clip. You just watch it. So I just keep here for your reference. And because we don't have enough time, so let me skip. So finding documentation. So if you are not ready to create a project on Depositar, you may visit the first link to share some research data that you like. Or if you want to know more about user guide, you can visit the second one. And now we will welcome back Professor Zhang to join us the Q&A session. And thank you for your listening.